Hi, hello everyone. Hope you had a good break. This is a great honor to be on Scalar. I've been attending many times, never dreamed of presenting anything. Finally, I would like to introduce you to Michał. Michał is a very promising developer which I introduced to Scala 2 years ago, and now Michał is basically addicted to this. I hope this will one day translate into some good job. Me myself, I'm a developer for a long time. Started with Java in 1997 and Scala 2009, so been long around. And I have a good news for you. We are definitely not going to introduce any new effect system on this talk. So you can just sit, relax, have a good time. This will be very light talk about some success story. This is advertised as a case study. It's basically a summary of my experience of my last year working for some startup, doing software, and Scala was my obvious choice. Lambda was something new. I did learn, discovered during this time in more details, and same for GraalVM, native image. Yeah, so that's the plan. I said what did motivate me to do this. It's basically sharing the technology. We've built some small library, nothing complicated, but very useful, pragmatic. Probably I would love to have it 1 year ago, to not spend 1 year to master this. So my motivation is to share it back with you. And then I would like to do some small presentation about Lambda. Probably most of you know Lambda, AWS Lambda, but some refresher, some GraalVM and some scala-cli. And last but not least, some small piece of software which is on GitHub and you can take and use for your purpose. I would like to start from the end part. That are key takeaways from this session. If someone fall asleep or get bored, or this is something I would like you to stay with, just 3 simple thoughts. One, that Scala really plays very well with Lambda, even if there is no Scala choice anywhere on AWS documentation. It really works, brilliant. Second, we have very good tools, scala-cli. I fall in love with scala-cli as a tool, as a build tool. It's really cool technology if you didn't try. It does the job. Same for GraalVM. We are using it just for one small task, but it does it very well. It didn't break yet. And the last thought is that really developing your own Scala Lambda is something very fast breeze. We prepared some template on GitHub in the cheat format. You can just run one command, have everything set up your AWS account, and then deploy something which you can start using on the internet, which is fabulous to me, because I've been mostly raised in the corporate environment when building things, setting up things, running things is very complex, takes ages. Here, you can do it after your lunch. Yeah, so this is a question I've been asked a month ago on the meetup. We presented this as a warmer to see if there is an interest in the topic and why. Why Scala? If you can use beautiful languages like JavaScript, Python, why to bother with Scala? And I think this primary for me is it's my language of choice, but also I think this is a very good language. Not just my choice, just very good language. And if you have a lot of software already written for your company or for your private projects, you can just directly use it, reuse it. So my task 1 year ago was to build a piece of software for a startup, and I was the first and for some time the only developer. So the decision was to basically do something simple. I made a very big mistake, and I started with step functions on AWS, which I heard a lot of talks about, and I decided to try, but it didn't really live up to my expectations. And then I decided to use Lambda to slowly walk back to rewrite part of this into Lambda, and because it was very easy integration between step functions and Lambda, I searched for some way to do Scala on Lambda. I found some Java custom runtime that didn't really be so friendly as I was expecting, so I decided to dig deeper and do something on my own. But why to use Lambda at all? I think there is a lot of discussions. I would like to maybe hear your voice. What's your expectations? My one is short and very small startup project. If you have experience, I will love to hear back. This is a set of things which came to my mind. What might be the reason for going Lambda? Definitely for me, Lambda is AWS Lambda. Way of deploying software, but also some way of building software, system design, a lot of choices. Some of them are definitely positive for me, like event-driven, stateless, easy to test, very stupid, simple concurrency model, as simple as possible. Just run everything single-threaded and shut down when needed. Seems like a waste, but reliability is enormous. You can't really fail this way. But this comes always the most when we are talking about AWS Lambda. This is simply money. For some people, this is too expensive. For some people, this is very generous free tier. I found myself that, especially for small project, small startup, your own project, it can be really the cheapest way to go, almost free, to develop something and scale it up for a long time until some bills will come. Mostly bills will come for CloudWatch works, some other parts. Lambda never occurred to us to cost anything for a long time. And because you're writing in the solid language, you can always wrap this code if the scale is really high into some target system, Zapier or some effect systems, whatever is your choice. So, and now it's a part where we would like to show you a bit about how. This will be mostly Michał part, to show some technical bits about this. And this is like a set of ingredients, technologies, which I did use. First and foremost, Scala. For me, expressive, concise language. Access to large ecosystem of already existing libraries. Fantastic libraries coming from the HOE, which I did use, like Vue.json or from SoftwareMill HTTP for HTTP connectivity. Of course, AWS Lambda, we just talked about. I like this no ops part, that if you are just only a developer on the project, you have to think about where to put your resources. And everyone on the business side wants you to put your thought and thinking into solving business problems, integrations with partners, and not just tinkering about how to run servers and scale them up. So that saves a lot. Of course, GraalVM, my discovery was that really startup times are very fast. Nothing especially new, but still some finding, and the deployment packages are really the smallest ones, which also turns into money because you can deploy things on Lambda if they are small for free. Otherwise, you have to pay for some storage and scala-cli. No fast build tool, a lot of batteries included, and fabulous for scripting. I really discovered how nice it is to write scripts in Scala. Like a proper code. You can use all your tricks, all your skills to make things happen where before I was always struggling with some bash, Stack Overflow, searching. All right, send this for me home.
Okay, so what is AWS Lambda? Well, as we know, it's a serverless compute service that helps us to run our code without managing all things like scaling the systems, other services. So let's look under the hood, how exactly does it work? So we have our function, it's in an execution environment, and it contacts to the external world by the runtime API. So down below we can see the life cycle of the Lambda function. We have an extension in it, the runtime in it, and the function in it, all the like setup things and stuff. Here we invoke our method, and we shut it down. All the methods communicate by a next API. So here we can see some methods used by the runtime API to communicate with the external world. Yes, but how does the exectional model work? So the Lambda, it doesn't have to create all after again the execution environment. We can reuse it. So let's say, for example, we init the first function. Yes, you can see that the requests from 1 to 5, all the available execution environments are currently busy. But the 6th request sees that the A execution environment is currently available, so it uses it. And that's how we can reuse the resources that are available. So concurrency. It's a number of in-flight requests that our function is currently handling. Every function receives one execution environment. So when the function receives more requests, it scales up the executions environments automatically. So there's a problem called cold start. So when we run our Lambda, we have to download the code. We have to start our execution environment, and that takes time. Of course, we can use provisionized concurrency. We can initialize the code before the Lambda runs, or we can use snap start, but still this problem exists. Of course, it's just 1% of invocations, so it's not so much, but still it poses a problem. But we'll see later how we can deal with that problem. So AWS Lambda supports multiple languages through the runtimes. Runtime is an environment that provides basics operation like responses between the Lambda and the external world and so on. The main languages, they have their own environments that are supported by the AWS, but we can also provide our own runtime. So, a runtime is a program that runs your function handler, yes? So, to implement a custom runtime, we have to have in mind that this program has to read the events, give the responses back to the external world, and also the entry point is the executable file named Bootstrap. And there are two ways to provide this file. We can use container image, but this option costs because we have to store this image on the AWS. And there's a second option, the zip file. The zip file could be the binary code, or it could be also a bash scripts that we could use. Yeah, the memory. You want to add to something?
Yeah, so there's probably internals which are at some point becoming very important, especially about this deployment and packaging, where GraalVM, for example, helps because it can reduce really our package greatly. One thing which I find really interesting is performance, because AWS really is a fast cloud, and we can expect that. We always expect that it will never fail. And so AWS Lambda, for the scale which I've been working, was basically always available and always reliable. Of course, the more you start using it, you will hit some limits. Interesting fun fact is that we have this parameter of memory, and this is strictly bound to the share of CPU we get. But because we pay for memory, it's always decision: do we want to have more memory and more CPU and pay more for it, or not? If you have CPU-intensive task, definitely helps. If you're like me, you're just calling other services, orchestrating. It's maybe better to have less CPU, pay less, like 1/10, and then simply wait for external events. Or just, if you really have to wait a long time, it's maybe better to have a better design. You can, for example, make an event to the queue, which will get back to you after some time. You will keep checking. Also timeouts. Lambda can run maximum 15 minutes, no more, which seems ages, of course, especially for connected applications. But practically, most of the time we are connected through API gateway, which has a limit of 30 seconds. So that is like an upper limit for answering synchronous requests to Lambda in practice. And still, you still have to pay for every second. So sometimes it's better to redesign your Lambda to work more in the event-driven mode. Here is a bit about this famous pricing. We of course pay per amount of memory per second, and gigabytes. This free tier. Disclaimer, we are not connected to AWS. This is not a safe speed, but I think this is very, very generous. And this is per month, so it's sometimes hard to hit if you are developing your own software. Or, which is interesting, what I found important, we all have production environment, but also we have other environments, testing, staging, different sandboxes. And with the classic model where you have to deploy your container servers, you have to pay for everything. And that becomes a huge chunk of money, a big bottleneck. With this approach, basically, there are some environments where you only hit them a few times a day, or you expose to your partners, and they come one time a week to check something. You don't have to pay. But still you can build everything the right way. You don't have to think how to scale it down, how to pack it together. Can be just a proper solution, proper architecture, same you have on production. Just it scales differently in this case. So everything you will pay on production, you will save then on 5 other environments probably very quickly. I did some, this is my chart, did some research into how much it costs to run Lambda, which takes like 3 seconds duration, which is quite long, which uses full 1 CPU, which translates to 1.7 megabytes. And here on the horizontal axis we have requests per month, 50,000. 500,000 up to 10 billion. And you can see that up to some level, like for example, 10 million is just peanuts for most of the businesses. So it's not really that scary. And if you go upper, it's probably better to either go for provisioned Lambda, because this is on demand, or just plug your service into server and scale it a different way.
However, the JVM has some challenges, mainly because it was designed to run long, let's say it was designed to run long in its applications, and the AWS, the applications, they start up quickly, they shut down quickly, so the JVM isn't the best solution. It's mainly because of the GIT compiler, which has to interpret code line by line, even if it has the code cache where it can store the hotspots. Still, it's quite not really efficient for the AWS Lambda. So we have 2 solutions. The first one is snap start. So we do actually all the same like for the normal Lambda, but we take a snapshot at the end of the disk state. We encrypt the snapshot and we cache it for low latency access. And when the Lambda is invoked, this snapshot, it's let's say it's brought back to life, so that the Lambda runs much quicker. But it also has some drawbacks. Let's say your Lambda wasn't invoked in 14 days, so then it just is terminated. And another thing, when you establish a connection with a database, the token could change, so that could also pose some kind of problems. Here's our scala-cli command to generate, to use snapstart. We generate a fat jar. We use the Java runtime provided by the AWS. The second solution is GraalVM. So we create a binary which stores only things, functions, the code only needed by the program. The substrate VM, the virtual machine from GraalVM, it also compiles itself into the binary. So it has, as you can see, it has many benefits and so on. It also has, there could be a drawback of reflection. However, it is quite good dealt with in Scala-free. So, but if you wanted to in some way prepare for the reflection, you can also pass the JSON file where you could include the methods that could be problematic in terms of reflection.
Yeah, what we see on the screen is basically a new Scala command, which is basically scala-cli. And you can add power to this by this minus power. And this is the command I'm using on production to package my software. Basically, it's provided by scala-cli out of the box, and it works. That's a piece of software which I extracted from my solutions. It turned out to be like few repositories, but this one is just responsible for the runtime, which is a small glue code. It consists of only few types, where the Lambda runtime is the most important. And also, this is the contract I'm using for defining my lambdas. There is one interface for Java coming from standard Amazon library called request handler or request stream handler. I have another one. It's called event handler. It's, I think, more Scala-idiomatic. It's basically handle request method where we implement our application code, takes the input, string, return string, have some implicit context of lambda parameters, and some our application context which we can define. This is the abstract type, but you can always make it into your type. And there is some way of injecting this application context at the beginning, even before the first execution, by this initialize method, where we take lambda environment, which provides us system variables. Some information is coming from the host interface, and we can produce something. So this is an extremely simple interface. This is how it can be then implemented as a very trivial lambda. We see that we just take some class which extends simple lambda runtime is just lambda runtime with type application context being unit, so we don't expect any in this case. But since our runtime is part of our lambda class, we have to start it somehow. I'm providing this object where there is this main method which basically instantiates lambda and run it, because this lambda runtime does not run automatically. This is because I also want to have a way to instantiate it and test it without this overhead of running the protocol of communicating with the host environment. That's a way, for example, to run it locally and test it on your local machine. I got some piece of software, it's called localhost, so you can simulate locally AWS part of the contract and protocol, and you can provide your script to run your lambda. It can be either this, or you can add bootstrap here, and you can see here what will happen in the terminal, basically. There's also a way to run it with some improvised web browser. This is very simple. I didn't do it to impress you with my front-end skills. They just built HTML code which is packed as a string into Scala class, so it must be very simple. But it works. You can still achieve this. So you can basically start your Lambda locally, connect it to some AWS systems, and test it here before deploying to the production. So it's a quick feedback loop. This is about testing. And testing is, we know, the most important exercise of every developer. So testing this Lambda is as easy as instantiating it. There's a special test method which takes this input and provides output. If you want, we can also provide another parameter, override our environment variables. Or we can design this Lambda that way that it also takes some objects which will be, for example, stubs in the constructor. So it's just pure object programming, pure Scala. This is a more complicated Lambda we see now, initialize method, which produces something based on environment variables. Environment variables can be defined on the AWS console or via Lambda API, and it's an important part of customizing our Lambda behavior for each environment or for each instance. Each type of instance, if you deploy to different names. And we see that in the scale application context is areas for config, and this config will be then passed as an implicit parameter to every our invocation, initialized nodes. Here is how we can make this environment configuration in the test configurable. So you can pass different environment variables. And here is even more complex example where we basically make our application context named tuple. So we produce two various config and some AWS client library which we initialize based on our environment properties. The key thing is that on AWS Lambda, these AWS secret keys will be provided for us as environment variables. So, and we are run of time now. So I'll just scroll this a bit quickly. This is like what it looks on the AWS console or Lambda. We also have some template. In this template, we have a complete system to build and deploy your Lambda using GitHub Actions. The only thing you have to configure is AWS account and the role. This is how it works. Here was about the sizes: assembly jar, each jar, fat jar. The function zip is our packed bootstrap. So the upper is very simple. Example Lambda. It's almost no difference. But here is my production code. You can see it's much, much larger. Here, I have to say, I'm not using Lambda like I just show you. That's not true. I'm actually packing multiple functions into one function. So like each function have a set of handlers. So each function can basically handle multiple different requests. And to make it organized, I came up with something like this event handlers, where we can basically define, where is my slide? I lost it somewhere. So we can basically organize our Lambda to handle different type of events. Basically, API gateway events, they have special format. SQS events, they have special format. And generic events, which are plain JSON, which you can send from Lambda to Lambda. Or we can send from API gateway using custom templates to Lambda. That's an example. One nice thing coming with this custom runtime is logging. I put some effort into making logs into structured format. So we are logging into CloudWatch as JSON. And we're adding some metadata. You can also put your own metrics here. If you see this part, logs, this is basically one log event which captures all your logs from one invocation of your Lambda. And not just logs logged with log method, but anything you dump to sysout will be nicely cached and presented. This can save your life on production if you have to debug some issues. We also pack request back to response on the response, so you can filter your logs, searching for some cases. We can skim this. This was about like cold start duration. Here are the logs you can see for each invocation. We basically get request response logs, and this is it. And then you can debug your application in production with Createase. This is how it looks on the CloudWatch. You can clearly see what was the request, what happened, what was the outcome of your Lambda single invocation. That saved me hours of like debugging external systems integration in practice. Otherwise, these logs are scattered and totally disconnected. We did some performance metrics. You can see here this cold start. It's basically first invocation. It's always very long, and then it's quite stable. I did some of them, but we don't have, I think, time. The fun fact is that there's everything for GraalVM. There's like first ramping up from 2 to 50 users. Here we have 50 users hitting already on the beginning. Here is what we get when we switch off logs. Logs makes it slower. For example, here we have 63 milliseconds. Without logs, 14. And this is pure Java. It's even better. So it's hard to say, but this is a very simple Lambda which just does simple echo. So there is no real business and logic class initialization. So everything where GraalVM could help, static initialization, filling up caches, this could help here. Right, and this is the seed. Also have here this QR code, so that's a command one have to run, and this is what you get as a seed of your project. A lot of scripts for different purposes, also for deploying and